Hello students, class 10th polynomials. Let us continue the same topic. Today we will discuss the relationship between zeros and their coefficients. On the basis of this, let us discuss few questions from NCERT, exercise 2.2. Question is, find the zeros of the following quadratic polynomials and verify the relationship between zeros and their coefficients. And these are the questions given to us. How we can solve them? Let's see. Now let's see the first solution, in which what will you learn? First you will learn how to make factors of quadratic polynomial, which you already done in earlier classes, 8th or 9th, and in 10th also we have discussed. Here it is given to you x square minus 2x minus 8. First we have to split the middle term. You can see here minus 2x can be written as minus 4x plus 2x. And then in x square minus 4x, x is common. What is left? X minus 4. And in 2x minus 8, 2 is common. Then what is left? X minus 4. X minus 4 is common. That's why we have taken x minus 4 here. And what is left? X plus 2. These are called factors of this polynomial. If first factor equal to 0, for finding the zeros, then we will get x is equal to minus 2. If second factor equal to 0, then we will get x is equal to 4. It means minus 2 and 4 are called zeros of this polynomial. Let us assume one factor as alpha and other is beta. Means just we are writing the name. We are giving the name to them. One is alpha, other is beta. Then what relation we know? Sum of zeros is minus of coefficient of x upon coefficient of x square. Let us substitute the values of alpha, beta, and coefficient of x square. Alpha is minus 2 and beta is 4. And this minus sign as it is. Coefficient of x is minus 2 divided by coefficient of x square, which is 1 here. Means after simplifying, after substituting the values of all, we are getting LHS equal to RHS. Hence it is verified. This is first relation as sum of zeros equal to minus sign of coefficient of x divided by coefficient of x square. What is second relation? Product of zeros, that is alpha into beta, equal to constant term divided by coefficient of x square. Alpha is minus 2, beta is 4, constant term is minus 8, and coefficient of x square is 1. After substituting the values, we are getting minus 8 equal to minus 8, means LHS equal to RHS. Hence it is verified. These two relations are verified. This is called the relationship between zeros and coefficients of polynomial. On the basis of it, let us discuss the next question, which is, you can see here, second is, four s square minus 4s plus 1. Let us split the middle term. After splitting it, we are getting minus 2s minus 2s. You can see in between these two, 2s is common. Then we can take 2s minus 1, which is common out of these two. And minus 1 is common. After taking it, we are getting 2s minus 1. As 2s minus 1 is common in between these two, let us take 2s minus 1. And this 2s minus 1 is left, means we are getting again two factors. If first factor equal to 0, then we will get s is equal to 1 by 2, and second factor equal to 0, we are again getting s is 1 by 2. Means we are getting two same factors, same zeros, that is 1 by 2, 1 by 2. Let us take it as alpha and beta. First factor is alpha, other is beta. And the relation is alpha plus beta equal to minus times of coefficient of x upon coefficient of x square. Let us substitute the values. Alpha is 1 by 2, beta is 1 by 2, minus sign as it is. Coefficient of x, x means coefficient of s here, because in place of x, here it is s, which is minus 4. And coefficient of x square means coefficient of s square, which is also 4. Therefore, replace it, and we are getting LHS equal to RHS. Hence, it is verified. Second relation is product of zeros is constant term divided by coefficient of x square. Alpha is 1 by 2 and beta is 1 by 2. Constant term is 1 and coefficient of s square is 4. Therefore, by simplifying, we are getting LHS equal to RHS. Hence, it is verified. Both the relations are verified. You can see in both the questions that there are two relations between zeros and coefficients. That is sum of zeros, which is equal to minus times of coefficient of x upon coefficient of x square, and product of zeros, that is constant term divided by coefficient of x square. In both the cases, in both the questions, you have verified these two relations. Similarly, you can continue other questions yourself. I can show you same process we followed here. In the third question, make factors, got zeros. Let us take them alpha and beta. Let us verify these relations. Similarly, in the next question, fourth question, you can see here we are getting factors as 4u is common. Therefore, directly we are getting factors, and by taking first factors as 0, we are getting u is 0, and other factor is 0. We are getting value of u, which is minus 2. 0 and minus 2 are zeros. Let's take them as alpha and beta and verify the same relation, sum of zeros and product of zeros. So these questions you try yourself here, and I showed you, you can read them properly and then find out the same relation which you have done in earlier questions. Same question, question number 5th, in which again we are getting factors, and the method we are applying here, a square minus b square, that is a plus b into a minus b, and by taking one of them as 0, we are getting the value of alpha, and other is 0, we are getting the value of beta, which are called zeros, and relation we have verified. You can see. Same question, part 6, you try yourself. These questions you try yourself. If there is any problem, you can discuss with me also. Now let's discuss second question of the same exercise, in which what is given to us, we have to make a quadratic polynomial in which what is given, sum and product of zeros. Means in first part you can see 1 by 4 is sum of zeros, and in the second minus 1 is product of zeros. Means sum and product of zeros given to us, and we have to make quadratic polynomial. And how to make them? Let's see what is the method. You can see here the polynomial is x square minus sum of zeros into x plus product of zeros. Let us replace alpha plus beta, which is sum of zeros 1 by 4, and alpha beta, which is product of zeros minus 1. By simplifying it, we are getting it, and by taking LCM, we are getting this quadratic polynomial. Similarly, you can see the next one. Here it is given to you sum of zeros, that is root 2, and product of zeros is 1 by 3. Sum of zeros root 2 and product of zeros 1 by 3. And the quadratic polynomial is x square minus sum of zeros into x plus product of zeros. Let us replace the values. Alpha plus beta is root 2 and alpha into beta is 1 by 3. By taking LCM, we are getting this quadratic polynomial, and same process we can follow in other parts. Do you try these questions yourself? I think it is clear to everyone. You can see here the same process we followed here. Now goodbye to all of you. Revise them properly. Ask your doubts if any. Goodbye.